this today. So this week we're gonna have to have a plan because we don't want to have the recording or the server hanging or in an infinite loop. And so one of the things that we can troubleshoot this week is if we have some hanging, then that might point us to a certain part of our code to say, okay, let me make sure that my format's correct. And so this week we have to follow explicit instructions. We have to have a plan. This is where you want to inventory the repo, take a look at it and see what's available to you, come up with a plan, and then implement the plan. This is also where you might want to do a few lines before you would move forward. So few lines tests, and so that we can catch things early. I told my group about the experience I had with the server, and I literally spent over an hour all because I had an extra space in my server code, in my header. And it was a big headache because I'm looking at everything that was actually correct, and literally it was just the space that was wrong. So you're looking at everything and saying, well, I'm doing that right. And it was something that I could have prevented by taking a look at the early code. And so I'm not perfect, but I share that example with you because I don't want you to have to go through that same headache. So test your code out, test it out. I tend to kind of code fast sometimes, especially when I have an idea in my head and I'm just like, all right, let me just get this out and see if it works. And then if it works, then great. But sometimes that can cause a problem. So I share that experience with you so hopefully you can avoid it. But also so you can troubleshoot. So immediately when you're seeing something hanging, you can say, all right, let me check this. Let me go check the header. Let's make sure it's formatted correctly. And we're going to talk about the formatting today as well. So let's go to some of the questions you guys have. And you guys actually have some really good questions today. Starting off, your question: with UDP, you lose packets. How are they lost? So the most common way is probably with a router or other computer along the way was simply overloaded. So it was busy doing something else, and then like two things are coming in, and then the other one is ignored. So it's handling the first, so the second one is ignored. It could also be other things like your router goes down, or someone sticks a back hole through a fiber cable, or water got past some insulation or copper wire and caused signal noise that corrupted the packet, and different things like that. But the most common way is just that so much was sent that it was doing one thing and it just lost the other. You know, like when you're talking to someone and someone else is trying to talk to you and you kind of focus on this person, and you didn't mean to ignore this person, but they kind of came in while you already had a conversation. So that's kind of how UDP works. As far as how you can lose packets. How would you know which layer of the network stack is causing a problem? And so, let's see. Well, let me answer this question first. Will we work with both UDP and TCP on this project? We should be using just TCP, I believe. Also, HTTPS, and we'll be using HTTP. But I don't think that it's very difficult to implement HTTPS. You just add S, since the operating system is handling that part of it for us. And then the C libraries that are vital for using sockets. I think the socket part of the code, which we'll go over, is kind of done for us. But I think it's sys/socket.h that's going to be included for that. That's the library that's going to be included. And let's see here. That's it, that one, and that one. Okay, let's answer Kat's questions now. Okay. Send function and the recv function have a parameter for flags. Example of a flag. An example of a flag is, let me type this in Slack actually. And it can be used to send priority out of band messages. The remote program is notified by a signal that the data has arrived independent of the mainstream of data. Another one is here, but this one is not as common. Seems to have a diagnostic use, but it's kind of rarely used. And then if you want to research out of band data more, I got a link for that. But the practical one is the MSG/_OOB. It can be used to send that priority out of band messages. And so that would be an example of the flag. And then your other question, how would you know which layer of the network stack is causing a problem? So how this would work is that it's pretty much like a troubleshooting where we would, let's see. You have to learn how to troubleshoot the network problem. So you start with the lowest layer, and we have a link layer Ethernet connection to another device. So you check that. Do we have this link layer Ethernet connection to the other device? If we do, then we're going to move up a layer. Do we have an IP layer connection to the device? And then as far as connectivity is concerned, it's almost one of those. And then a TCP layer issue is usually a result of a layer below that. So presentation layer issues is HTTP, FTP, etc., something like that, tend to be program bugs. And then you just debug them as you normally debug your program. But you're just checking these wires for connections. Okay, do we have a connection at this layer? Do we have a connection at this layer? And then that's how we can kind of nail it down to a certain layer. Make sure we answered all of those so far. Michael's 1, 2, 3, check. Cat 1, 2, and then the question from Glenn's group. All right, cool. So now we answered those questions there. The challenge that I have for you guys, and I'll let you know that I would be doing this. Can anyone or a few of you help each other out? Name at least 3 trade-offs between TCP and UDP protocols, please.
Well, the easy one that I know of is that you can send more data more quickly using UDP, but the packet loss is greater.
Okay. Cool. Anybody else? Anybody else? TCP is more reliable, and it's more reliable because it has to do so many other things that UDP is not going to do. And so can you think of some kind of issue or negative effect for having to do more than UDP?
It's much slower.
I'm sorry, say that again?
It's much slower at making the data transfer since it has to go through so many steps.
Correct. That is correct. It is slower. So UDP is where we want to use that when latency or the quickness is better, but we don't mind if we lose a little something here. In which both UDP and TCP guarantee that all data arrives error-free, but we just handle it differently. And so TCP is more reliable. What's another thing? Anything else? We know that TCP breaks large data sets into individual packets. UDP doesn't do those same things as well. So let's look at the couple examples here where for each of the following applications, decide whether such an application would be better served using TCP or UDP protocols. The front page of YouTube, what do you think? TCP or UDP for the front page of YouTube? It could be hard to tell for things like that. But as far as that goes, TCP could be a great option because you can see the buffering, in which they don't mind waiting a few seconds for that buffering that takes place, right? As well as Netflix. So I would say TCP for YouTube and Netflix. You could go with UDP, but usually you see some type of buffering where they don't mind the wait for something like that. And then what about multiplayer games? UDP or TCP? Anybody? Let's see. Am I UDP? Yes, for games we want to use that UDP. Correct. Okay, you guys answer it in Slack. I wasn't seeing that. Cool. And then what about the last one? What was the last one? Let me scroll up again. Application for making phone calls over the internet. Would that also be UDP? UDP, yeah, correct. Why would UDP be best for that phone call, those phone calls? Yeah, and we might get dropouts and stuff like that. So we want to use UDP there. So awesome, because it's live. So recovering packets later doesn't help much. Cool. All right, cool, awesome. So let's talk about a few things here. So we watched the videos this morning, and so we know that the data sent over the network is just a sequence of bytes. A protocol gives it more structure. And so this is also important to remember because we're going to have that interview again on the sprint. And so this may be one of those questions. I actually haven't taken a look at the questions yet. But you have to understand that data sent over the network is just a sequence of bytes. A protocol gives it more structure. And so can anybody think of an example of how such a protocol works? There's one we can think of. It's kind of like you send a random string of letters or words, and it would make no sense. So we rely on the English protocol to tell us what data we can simply send and receive. And then other languages would probably, Spanish would be a protocol, French would be a protocol. And so that's pretty much what we're saying. It's just like, okay, this combined, these characters combined means this word means this, and so on and so on. And so, and then we even have, as far as like composition structure, where you have to have certain verbs and adjectives and nouns and things to make a complete sentence. And that's kind of how we have to be with the protocols. We have to kind of follow these exact instructions, because if we're missing something, it's not going to work exactly how we would like it to work. And so let's show the protocols on the network. So what I want to do, let me share my computer. I want to also show you guys this. This is actually available in the repo today. So let's share this screen here. And you guys can see my screen. You can see a simple web server in C, correct?
Yep.
Awesome. So this is kind of what we're going to be doing today. We can talk about this in a little bit, but we can come down here and we can get what is a web server? A web server is a piece of software that accepts HTTP requests, get requests for HTML pages, and returns responses. Other common uses are get requests for getting data, for RESTful API endpoints, images within web pages, and post requests to upload data to the server. Can anybody think about something else that we could do with a server besides get and post? delete, correct, put, yep, which we would be updating. So we can do all those CRUD operations, and everybody's done the back end portion before, so you should be familiar with this stuff here. But yes, we can perform those CRUD operations. Post is a stretch goal this week, but we will do the gets. So, and just like always, I always encourage you guys, if you do have the opportunity to stretch, but that shouldn't be on your mind originally. Take care of the MVP, but if there is time, I definitely encourage you to stretch because you might find it interesting, as well as sometimes that type of stuff is required down the line, maybe on the sprint or something like that. I haven't looked at the sprint yet, so I'll go into the sprint more later this week once I take a look at it. But what we have here, we have some reading. So we have some reading here. This LRU caches, we're not going to talk about today. This is going to be Wednesday, Thursday material. But let's take a look at the network background. And so what we have here is our network stack. So this is our network stack. And with our network stack, we have HTTP protocol, which handles our web data. TCP guarantees data integrity. IP deals with routing and delivery. Ethernet deals with sending data on the LAN. And, oh, that's not, okay. And the protocol stack is not a stack data structure, it's just the name. So it's just like stuff on top of each other. So it's not, we don't have push and pop functions with this, but it is referred to as the protocol stack. Okay, so I think this is kind of where Kat was kind of hinting to, well, how do we know which layer our problem exists? And so this is what we were talking about. We're going to check to see if we have connections, and this is going to give us different data. So how this kind of works is our data is in the middle, and then we have all of these different protocols or headers wrapped up in it. And a lot of this stuff is going to be handled by the operating system, okay? But here we have the application protocols layer, and this is just your www, email, FTP, etc. Transmission control protocol, which transport control protocol is kind of interchangeable, same things. TCP directs packets to the specific application on the computer using a port number. Internet protocol layer, IP directs packets to a specific computer using an IP address. Hardware layer converts binary packet data to network signals and back. This is your Ethernet protocol, okay? And everything is just kind of wrapped up together. And it's saying, okay, we start here, and the HTTP just handles, I want you to get something, and then it receives it. And this right here is what's going to give our data some integrity. And then this will deal with the routing and delivery. But HTTP protocol is kind of blind to what everything else is done. But it's on top of everything else. So it's going to use these other protocols to its advantage to do the work. But each one is kind of almost, it doesn't really care about the other. It's going to do its part, and then it just sends it out. And then your operating system is saying, okay, I need to wrap this up into this TCP header. And then I need to wrap this up into this IP header. And then it's just going to do the Ethernet header. And so it's going to take care of things for us. And we don't do this ourselves this week because it just would be more than a week of work. But a lot of this code is actually provided so inside of the repo. So some of the stuff that we're doing, like sockets, we're not going to touch the sockets stuff. So if we look at the code, and let's take a look at that now. Let's come here to SRC. And let's see, net.c. Yeah, so this is sockets. So this is, I think Michael's question was what type of libraries you use for sockets. And that's the one I mentioned, and that's what we have already in here. But a lot of this stuff is already done for you here, but you can kind of take a look at it. And I don't know. We have to understand how to work with code, existing code. So a lot of this stuff is existing for us, and we're going to have to figure out what we need to add in order to get the thing to do what we want it to do. So That's one of the files there that's already there for us. Today's work will involve what's already here. So this is what's telling you what's already here. Contain low-level networking code, contains functionality for determining the MIME type of a file, and file C contains handy file reading code that you may utilize, namely the file load and file free functions for reading file data and deallocating file data. And so when we come down here to the assignment, we will write simple web server that returns files from specialized data on a certain endpoint. And we'll go into here. So you're going to implement send response. So we want to kind of read over this and come up with a plan of how we're going to execute this. And we have a couple of guided projects that we're going to go through on some of this stuff so we can learn how to parse data. But let's start with the following. So can anybody tell me what a ping is?
It's a command that sends a packet to the server and waits for the response.
Okay, cool. Can anybody tell me like a example of where you probably saw a ping or where a ping would be used? I haven't gamed online in a while, but usually you care about the ping when you're gaming online, right?
Yeah, low ping means low latency.
Exactly. And so one thing that's available on our computer to do is we ping here. No, I did it. I did spelled it wrong there. Cool. So this is telling us how many milliseconds it takes for these pings to occur here. And this is going through, just giving us an example of how the ping works, how many bytes, and the time. And like, I think that was Farhan. It says low ping means low latency. So it means that we are not waiting too long for it. So cool. Let me stop this. I thought it stopped on its own. And then let's do another thing. So I want to trace it. And hold on. Let's see. Trace ER. Okay. Trace RT. No. Let me do the other one. Let me do this other one. Cool. So here we're going to use trace ERT, and I think it's actually trace route if you're using a Mac. But what this does for us is it's going to give us kind of the location. So we're trying to get to this port, which I think is like owned by Google 1.1.1.1. We're trying to get to that. And so, of course, I'm not directly connected to that. And so it starts off probably where I am, and it goes to this next thing. And it's kind of like the directions. Like when you're trying to get to a place, you may not be connected to a certain road that takes you to where you want to go. You know, I'm trying to go to the museum downtown Chicago. I live in Crown Point. And so I have to go to this road that's connected to this road that's connected to this road that's actually connected to the road that the museum is on. And so what this is doing here is it's giving us this, it pretty much checks a table and it says, okay, I am not connected to where you want to go, but I am connected to this road, which will lead you where you want to go. So it takes me to the next road. And then it's going to take, and you can kind of see the names in here too. We see chicago.com.net, comcast.net, and then it goes to, I don't know what that name is, but goes to this place, then it goes to this place, and it goes to this place, and then it's here. So it's like, okay, we found it. And it took us 9 hops to get there. So I hopped from my own place to this place, 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 so on, till we got there. And so it's kind of similar to ping because you can see how long it took it to get back. But this is how it happens in behind the scenes for your when you load a web address or a web application. And it happens super quick actually. So let's see. Trace. So what I want to do at this point is I will allow for questions, but we're also going to take a 5-minute break. So if you have a question, post it inside of the Flex channel, but we're going to take a 5-minute break. So we're going to kind of follow last week's lecture a little bit where they took a couple of breaks instead of just the one. Since we're going to go into some stuff that we really need you to remember about how this works. And then, so when we return, we're going to cover how packets are routed around the internet. So we're going to see how that looks when we return. So if you have any questions, post it in the channel. Otherwise, we're going to take a 5-minute break, return back at, it's 11:40 right now. So we're just going to say it's 41 and return at the 46th minute of the hour, please. Post any questions if you have them. All right, we should be back by now and ready to continue. Okay. All right, cool. So what we're going to do now is we're going to demonstrate an HTTP connection. So we're going to use Telnet. And if you try this on your own computer, I actually had to make this, it's on Windows, but I had to make it available for use in Windows. So it may not work. You might get some type of error message, and that's probably why. I'm not sure if you have to do that on the Mac though, but you can just kind of follow or watch me do it. So it won't actually be necessary for you to do yourself. And so I'm going to telnet example.com 80. And so it's showing it's going to try connected to example.com, and it's waiting here. So what is it waiting for?
Send.
Right, it's waiting for me to send something to it. Exactly. So remember how the handshake works is that it's like, okay, we're connected, and now it's waiting for me to actually communicate with it, to send something to it. So I'm going to just say, hi there. It should understand that, right? Oh, it didn't. So what does that 501 mean, and why did that happen? Why didn't it understand hi there?
It's not ready to receive request.
Well, it's ready to receive a request, so you get close to it. What about my request?
It's missing an HTTP header.
Right, we're missing the header, and so pretty much right now it's like I'm speaking French and it only knows English, so it's just I don't understand that, and so it's going to spit back this 501 because I don't understand the language you're speaking, or you're not following the protocol, so I can't give you anything, okay? And so this is what I have to stress on here is the first thing is it's going to sit there and it's just going to wait until we give it something and say, hey, we have to communicate. So it'll just sit here and wait until we actually communicate with it. And I can just type a blank line there, and that's not going to do anything. So that didn't work. And I can just come in here again. And so this is similar to how we can provide our data. So we're not going to say hi there, of course. But if we do not provide the correct format or follow the protocol, then it's pretty much going to read it as if we typed hi there in there. So this is why it's important that we follow everything to the letter. So let's try to make a successful request. So we want to do a GET request. And again, GET request is all you're going to need to do this week for the MVP postage stretch material. But we need to start our connection. So we're going to start that up there. And now we're going to get and then now I'm going to say hosts. And now connection, and we always close the connection. So if you notice there, I had to enter a second time. Hopefully you noticed it. I needed that blank line. So this, or where was I? This portion here was not good enough. It needed that blank line before it actually returned data. So hopefully you noticed that it paused there, and I'm just going to do it one more time so you can really notice. Much emphasis on following the instructions, and we need that blank line. So I'm going to put my get /HTTP 1.1. What did that do? That didn't work. What did I do? So I did something wrong. Oh, I didn't put the slash. I put a colon. So that was a good example of how a simple typo cannot give us the results that we're looking for. I didn't do that on purpose, but it definitely puts emphasis on the point that I'm trying to make, though. So git slash http slash 1.1, and then now we're going to host www.example.com, connection, close, and you can see it's waiting there. It's waiting for me to do something, and it needs that blank line. That blank line there is what's going to actually give me something back. So 200, does anybody remember what 200 means as far as when we do a GET request?
Everything's okay.
Yes, correct. It's successful. And we're gonna get some information that we don't need back. Now, you're not gonna have to worry about this stuff here. We're gonna have to worry about our content type. You could pass a date, but I don't think that's required. E-tag and expires, last modified, we won't use that. The server, vary, xcache. We will have content length, and we will have a connection close. So we will have that stuff in there in our version this week. And here we have this body that is actually returning from our request. So even though we just did this by hand, we could write code, a program to send and receive these bytes instead. And so let's see. Let me see if I can mute everybody now. I'm gonna have to do that. Someone's not muted, but who is that? Hey, Andre. Thanks. Thanks. Oh, no, you're back. You just turned it back on. Okay, good. And mute all. Let's see. Let's do that. Cool. Awesome. I just found that else I would have did it before calling you out, Andre, but I couldn't find it. So cool. So what are we going to do now? We are going to, so the steps for the web server, what are the steps that we need to take for a web server? Well, those steps will involve, let's do this, replet. Let's create a new replet. Steps for web server. So what is the first step that you think would be? And please type in Slack for me. What's the first step? Correct. Not formatted correctly, awesome. Sockets. Okay. So Michael, can we be a little bit more explicit exactly what we would need to do? Receive requests. Yeah, method that can receive requests. So the first step here would be we're going to start listening for connections. Okay, similar to just what we just did. Before we actually sent our request in, we got connected to something, and then it was listening to see if we're going to receive something, right? And then our next step is when a connection arrives, receive the request data. Okay. So when we receive that data, it may not come just like, so does it listen on infinite loop? Well, just like it's not going to move anywhere. For example, once we got connected, it's waiting for us to do something. So it's going to wait. It may even time out. It all depends on how it's set up. So it may time out after a certain period of time. But from my experience, it's just waiting for us to send something. So it's just hanging there and just like, give me something to do. Give me something to do. But so when a connection arrives, we receive the requested data. Yes, that's the next step, Farhan, correct. Parse the request. Why do we need to parse the request? Why would we need to parse the request? Because it will be all the headers and you need HTTP header. Yes, correct. So we kind of have to understand it a little bit. It's not going to come in this great uniform way where it's just going to immediately be understood. We're going to have to parse it. And what would be the next step? And if you remember, after we sent our requests, we received something back, but if we're doing the server, we're going to have to actually perform that action of providing the response. So before we would actually send the response back, Farhan, we actually would have to build it. So we're going to build our response. And then we're going to send response. What's the last step? So the last step would be to close the connection and wait for the next one. No, it's cool, Farhan. I definitely appreciate participation. So always, that's all we ask is everybody try their best. And a lot of times in lecture is where you want to provide as much as you can. You want to ask as much as you can because once you're starting to implement, you want to code. So that's where you want to code. So if you're in a meeting you get a job at an organization and you're in a meeting and they say, okay, we want you to design a server. And you need to, okay, well, what does it need to do? What type of information we're going to be working with? And this and that. You're going to ask all of these questions because once you are back at your desk to implement, then they're going to expect you to provide some code or actual program. And so there's a time for questions and time for participating and trying to get feedback, and then there's a time for coding. So this is the time where we want you to ask those questions. So your job right now is to think of, okay, how is this going to work? How am I going to implement this? Can we get an example like this or that? And then when after lunch, you come back and it's your job to implement. So so never feel bad about asking a question or providing something. Even if the answer is wrong, at least you now got that out the way so that you can implement something that much better because you know that it's not correct. So so let's see how this is going to work. Demo parse. So once again, I showed you, like, we don't care about a lot of this stuff here. So but we're going to receive, we need to parse the data so that it's going to look like this pretty much here. So how is this going to work? Let's come on over and take a look. So let's go to main C. And do I need any other libraries? No. Cool. So we're going to have something that's going to hold HTTP requests. Okay. So it's going to look something like this. Let's just do the one that we did. So what I'm doing right now is I'm posting the same information almost to what we did previously, only it's going to be similar to how it's received. And so you see me adding a few new lines here, and that just represents the same type of lines that I had in this part of the code. So you saw when I typed this stuff in, it was all on one line. So I put this on one line, this on one line, this on one line, and then I had a blank line. So let's go and parse this. So how would you parse this for everybody who is from the web stack portion at Lambda School? How would you parse this? What type of function would you use if you were using JavaScript?
I mean, you would separate it out into an array, right? Like all the values.
Correct. And that's exactly what Kat's saying. You would use split. Correct. So you would split this. Unfortunately, C doesn't really work that well as JavaScript to have a split function. So we're going to have to use a different method, but yes. And so part of the reason why you're doing Python and C is to kind of think even deeper to what JavaScript is doing behind the scenes. And so that's why we asked that question there, so that you can kind of think, hey, you know what if I saw this type of problem in JavaScript? We would use split. And so let's see here. What we want to do is I want to have the char array here. I'm going to put 200 there. I'm going to have a path, 8192. And we're going to use scanf. All right. We're going to use scanf. And I'll post a link. I think we've talked about scanf before. Have we? Right? Or we used it at least for one thing, I think, in the past. But I'm going to post a link in case you're wondering about that. And actually, let me just go to the link real quick and take a look. So library function, this is the prototype. We formatted input from a string. Following this declaration for scanf function. This is the C string that the function processes as its source to retrieve the data. This is the C string that contains one or more of the following items: white space, character, non-white space character, format specifiers. Okay, cool. So what are we gonna do here? So what we're going to do here in this part of the code is we're going to scanf, no, scanf, s comma, snf, method path. So we're just breaking this down so that once we get to that space and things like that, we're going to stop new line spaces. And so and that's pretty much what I was just reading there for you. And so if we look at this here, let's print f method /%s for our format specifier. Let's create a new line because I'm going to print both the path and the method /%s/ new line, path. Let's see what this looks like. I have an error probably that I didn't catch on my own. Semicolon, semicolon. Ah, there we go. I need a semicolon right there. And so we have method gets, we have path, foobar, and 1 second here. Is that correct? 1 second, because I think it's supposed to look a little different. HTTP 1.1 / host. Okay, so we pretty much parsed our method and our path out. So we have our foobar path that we parsed out. And, oh, okay, cool. This is what I want to do right there. And this is what I want to do right here. There we go. So we should have this string here and this string here. So this is our method. This is our path. And we can use this almost the exact same code for parsing the data once we get our request back. So I am going to share this here right now with you. No, I don't want to. I'll just share the link. I'll just share the link. But this is pretty much how we're going to parse the data. We can use scanf. There may be other ways to parse the data. I would recommend using scanf because, first of all, you have an example. So unless you know something exactly, okay, I would do it this way, or I've done it this way before on a different project, I would use the example that we're giving you. So hopefully we don't hear people saying, okay, I was searching a different way to parse. If you don't absolutely know something already, then I would use scanf. So move forward with that, especially because we're providing you with an example of how it works. So that should be one less thing that you have to Google today. And cool. So now let's go ahead and press forward here. So now we're talking about which step here. So we're parsing the data. Now we're on step 4 where we want to build the response data. Okay. And like I said, the socket's already set up for you. I think, Michael, you mentioned the sockets. That part of the data is going to be set up for you, but let's build the response data. So when we build this response data, it pretty much is going to look like this, only we don't care about. So I'm going to keep all this stuff in here, but I'll show you a different version for the part that we actually care about. Okay. So see, so we're not going to care about this, but we do care about our content type. Can you tell me why we care about content type? Can anybody tell me that? Server wouldn't know how to send back without the content type. Correct. Can you give me an example of something that the server would need to know? Like an example, what would we send back? Give me an example versus. Like what are some things that we can send back? Content type, mem type of the content of the body to be rendered. Text HTML, text plain, image, GIF, multi-part form data. Exactly, Kat. Yes, yes, that's what I'm looking for. I'm looking for that answer there. And you're exactly right, Michael, but I'm actually for that explicit data because we want to prepare for interviews. So interviews, we want to provide the explicit answer so that we can impress someone. So that's what I'm doing there. I'm probing you for that so we can be in good habits. But you're exactly right. Server wouldn't know what to send back without the content type. And so that's why I asked for examples. So we would have to tell it exactly if it's text or HTML, if it's an image or GIF, whatever. Awesome. So can you tell me why we care about the content length? Why would we care about content length? Buffer size. Yes, it has to do with the buffer size, Cat. And so pretty much we're saying, okay, continue to read until you get to this number of bytes. Pretty much what it's saying. It's kind of like we need an endpoint for the for loop. So we're saying, okay, for each character or each byte, go through here, but we need that stop point. So the content length is that stop point. So you're gonna read up until this point here. And so our content length is pretty much just our body. It doesn't include our header, but it's our body. So it's saying, okay, read this much and then stop. So that's why we would need to know the buffer size. So let's see. Let us build something out. I'm gonna need a library, the string library. So we're going to include that right away. Let's get rid of this printf statement. I'm also going to share this because this is a lot like what we can use in our code to help you guys out. And so let's start off with the response array. Let's just make it pretty big. And this is the rough number. Depending on what type of, this is one of the reasons why in your in the organization you would ask what type of data are we sending or receiving and this and that, because you want to know how big to make this, right? And so we're just going to use this number. It's pretty big, so it should cover everything that we wanted or we needed to cover. But you may not want to kind of allocate that much space if you know that you're going to be well under this number. So let's create our body. So what does our body look like? So if you notice the body that we use here, it's a lot of HTML stuff. So we're gonna send back, we're gonna have our body look like this. H1 tag, we're gonna say hello, world, H1, and semicolon. So we have the body. Now how can we get our length of our body? Can someone help me out? I need the length of the body. Remember that our content length, then which I probably should call this content length. It's going to be the length of our body. So how can I get that? I need to know the length. What function could I use? Sterling. Cool. Good job, Andre. So we put the body in there, and now we have our content length. So for this one, we're going to use a function called sprintf, and I think we used this at least one time, but let me share a link with you guys. We can go there, I guess. But I'll share this link. And this is hopefully to help you Google less. So by providing you these links, you can go there. I've already checked them out. So we're going to check them out right now so that we can have more time implementing. So it stands for string prints. Instead of print on console, you store output on char buffer. Okay. And so simple enough. Let's go back to it. And first thing I want to show you is this here. Because you probably never seen it before. So does anybody know what this line of code is going to result to? No? Okay, cool. So it's going to be equivalent to the following here. So what C is going to actually do is this. It's going to concatenate. Okay. So it's going to concatenate this here. And so that's pretty much what this is going to do. And so I'm showing you this is because we're going to use this technique to give our code some formatting so that it'll help us troubleshoot if we do have a problem, but it'll also help us format everything like we needed to have it. So remember, we had to have these lines. And so we don't want to have this big string of something similar to how we received it. We wanted to actually look almost like how it to actually be. So similar to this portion, how we provided it. So let's see how we can do this. So I'm going to do this because I don't actually need S. This is just an example. So the first thing we're going to do before we use print F is we're just going to print out the data so you can see how it looks. So we're just going to give it some random headers and things like that. So we're going to actually print this to the screen and not to our buffer. So we have our buffer here, but let's just print to the screen just so we can see how it looks first. And this is a good technique to use so that you are organizing your code. Then we would want to test it out before we just output it to the buffer. So you see what it looks like, and then you can spot an error, and then if it looks good, then you can use it and move forward. And we want to content length, and we're just going to give it a random length. But now I think this is the length we received before. And connection, close it, always close the connection. And then what else do I need? So I have my HTTP status, I have my content type, my content length, and then my connection is closed. What else do I need? Is this good enough? Or will I need something else? I guess is the question I'm asking. So let's go back here. Because I kind of want you guys to really get this part. So that's what the valid one. Okay, here's a valid response here. What am I missing? If you look at this here, What am I missing? And maybe this will make more sense. I do that. What am I missing? Empty line, exactly. Missing my empty line. So you can think, oh, that's an empty line. No, that's not an empty line. So we will actually need an empty line here. How can I get an empty line? Michael or anybody? Yes, Sean, correct. That's my empty line. And you would think that, oh, your code wouldn't break or, over just an empty line, but it is. It's not going to do what you wanted to do. It's probably going to hang because you don't have that empty line. And so I can't stress this enough. You're going to need that empty line. And then what if I want to put the body in? Where do I put the body? Or how can I put the body? Should be able to just go put the body right there. The body will come after the empty line, by the way. Oh. Percent S, right, exactly. And we're going to use percent S in just a second when we break this down into a sprint F, but I'm just typing it out right now. So let's print this. And I'm missing something else. Yes, I'm missing a semicolon. It's going to hang up on me. And there we go. We got our header. And we're looking at it. And we should be examining this thing. And say, okay, that looks good. And if it doesn't look good, we need to make our adjustments. But printing it out is just a good technique so you can avoid the C headaches later. We all have probably experienced one or two already with C. And so I can't stress enough, just let's code 5 lines at a time and test our code when we can. I know it's not always possible because certain functions are related to other functions. And if you don't have them all there, then it's hard to test. But when we can, try to think of a way that we can test the code out before moving forward. So we just printed all this out to the screen. How's it going to look to use sprintf? So now I want to provide, I want to use my variables. I want to use my response. So this is going to be my buffer. I want to use my body, and I want to use my content length, and I want to fill the response up with all of these things. And now I want to use sprintf. How is that going to look? Can someone help me out with that? And then remember that sprintf is a lot like printf, right? It's a lot like printf. Only we just will not print to the console and then we add some type of char buffer. So our output area is our buffer in this case for printf, but we're going to use response. And so we have to kind of pass that as an argument. And if we take a look at sprintf, we can see what's needed, right? So if we look at this and see what's needed, how's it going to look? What is sprintf going to look like? Okay, let's do this. I'm going to comment this out because we don't need it. That's just to show you how it's going to look. What's my first argument? What's my first argument going to be in sprintf? What if I told you it's the buffer? What would be my first argument with that hint that it's going to be my buffer? What is the first argument going to be? Let me comment this out very quick because I think I'm just going to copy and paste until it changes. Is it the size? No, it won't be the size. It won't be the size. So which one of these variables is my buffer? Yes, response. Response is my buffer. So I'm gonna pass in response, comma, and going back over here, what's next? What's needed next? So what is this constar string? What is that gonna actually be? Body? Okay. It won't actually be the body, so we're gonna do it in the same exact order. So let's remember the order. So behind the scenes, printf has this buffer which says print over here. So it's providing this information to the outputs buffer, and then what comes next? Our string. Everything in printf. Yes, exactly, Cap. And so we come here like this, and then what we're going to do is we're going to pass the length and pass the body. And I'll show you how we're going to do that, because we're going to get rid of you. And we're going to do %s, right? And then we're going to get rid of you. And we're going to do %z. So that should be my length, right? And I think I called that something else, right? Content. Awesome, awesome. Yep, and that's printf. So now we're passing all of these variables here. So here we didn't actually use our body or our length. We just hard coded some stuff in. But with printf, we could have printed that out this way as well, by the way. And you probably already know that. But now we're going to provide our variables. And so it's a good idea to, okay, I want my body to be a certain thing. So we make the body a certain thing. Okay, I'm going to get my content length. So I wouldn't, you could do this where you're doing string length here, but I would put variables out, because if there's a problem in your code, we're separating everything. And so this variable is going to serve this purpose. And if there's a problem, then I can go back to that variable, instead of having everything in one chunk, and then you have several problems and you're trying to figure it out. So this is virtually how our response is going to be. And again, we're only caring about this stuff here, and then of course our body in there. But so cool. So what I'll do is I'll share this. Let's take another 5-minute break, and then we'll open. You can pass questions in now too as well. Then we'll open the floor for questions and maybe go through the repo a little bit before I let you guys go today. So let's be back at the 34 minutes of the hour, and then post questions if you have them. And I'm gonna share this link now. Cool. So we should be back. I don't see any questions right now, but feel free to ask them if you do have a question. But so let's talk about the project today. So there's a lot of information in this project. It's not like the time you built the emulator last week, right? So it's not like the spec you just read last week, but there is some information that you may find helpful. But how I would start this is I wouldn't go through and just try to read every single thing, but you would skim over the information that is there. And so how we would go about skimming over what's there, or how we would go about creating this plan, is we would take this inventory. And so by taking inventory, let's just take a look, okay? So we start here, we come through, this is what I need to do, okay? This is what I have there. This is already done for me. Awesome. What is a web server? I can get an idea of that if I need a refresher. And then we have some reading: network backgrounding, double linked lists, LRU caches, mem types. And so we take a look at these types of things, and we may not have to go to these things and read them just yet. But if I do have a network question, I know I can go to this link. If I do have something on double linked lists that I need to understand or I need a refresher, I can go here. So in the beginning, I may not actually go to these places right away, these links, but I'll keep it in my head, or I may take a mental note or maybe an actual note and say, okay, I have that information available to me. So that's one thing I don't have to Google later if I do have a question on how this works. And so the assignment: will write a simple web server that returns files and some specialized data on a certain endpoints. So we have this here: should return a random number between 1 and 20 exclusive as text, plain data. So right there, I look and think, okay, random number. Now I'm from the web stack portion of Lambda School, so I immediately think, oh, I have a math.random if I was using JavaScript, but I'm not using JavaScript. So what do I have to get random numbers for C? And so that might be something that I might want to write down and say, okay, you know what, how am I going to handle getting that random number? And I just literally wrote that down because that's actually what I would do. So any other URL should be mapped to the server root directory and files that lie within it. For example, should serve the file. Okay, cool. Examine the skeleton code in server C and cache C for which pieces you'll need to implement. Okay, so it's telling me here, I think cache is Wednesday, Thursday. So we probably today will just be focusing on servers.c. So, but since it's the first day, it's not a big deal if you take a look at both just to see exactly what you're doing. So actually, I don't want to go there. I want to do this because I want to keep that open. So I'm going to use my right click and open up something because I want to remember where I left off at here. So I'll go back here. And where was I? We're looking at this. Okay, yeah, we're right there. So I'm looking at this here. I'm going to go to cache C. And where is it? Server C. Okay, cool. So let's take a look at these. Test with curl. If you don't have it, install it. So you can install it with curl. I believe you can test with Postman though too as well. So if you're not familiar with curl, then you might have Postman. And so you can test above URLs in your browsers. They should work. So actually, yes, they're saying you could test that in your browser. So I should be able to do this, right? And what is it gonna do? So it can't be reached. Okay. Where am I? Here. And so we take a look at here, send an HTTP response. We can see this header not found or 200 okay, etc. So they're saying they want a 404, which is not found, or 200 status, which means everything is good, right? Content type, body, return the value from the send function. So we get started off with max response size, and then we have this response similar to what we just had in our buffer. And we're saying, okay, cool, cool, cool. And then build response and store it in response. Implements me. Okay, so we have to implement this. And so we may want to check out what send is actually doing if you don't remember, because we've used send before. So that might be something that you want to check out. So I would simply just say C programming send function. If I didn't know what that was, we'll have to implement this point here. It looks like they've already doing the 404 response for us. Looks like we got to get a file, find starter body, handle HTTP requests. Okay, all right. We got a few different functions that we're going to actually need. And it looks like they're already doing some stuff for us in main. So we have to implement the function. So we kind of have the prototypes built out, and then we're going to have to implement some things. And this looks like it's find starter body as a stretch. So take note of that. All right, cool. So we take an inventory of that. And then we want to move forward here where I'm going to come down and spend some time inventorying the code to see what it's where. Write down notes, write an outline, note which functions call which other functions. Time spent up front doing this will reduce overall time spent down the road. That seems important. Might want to follow that. The existing code is all one big hint how to attack the problem. Okay. For the portions that are already written, study the moderately well-commented code to see how it works. There is a make file provided. On the command line, type make to build the server. All right, cool. So I haven't made anything. If you're wondering why I went to that website and it just was like not available, we haven't started the server or built the server yet. Once we go there, we should be able to test our servers, giving the results that we need. And so that's one way you're going to test your code out today. So we look at days 1 and 2, implement send response. So we have full steps of what we're going to do here. We see the total length of the header and body should be stored in response length variable so that the send call knows how many bytes to send out over the writer. So here's a good hit here, content length. We talked about that. It's only the length of the body, not the header. But the response length variable should be the length of the body, header, both header and body. So that's key there. It looks like we're going to have the date field, so we need a time and local time. And so let's help you out on one of those and provide you with a link. One thing you'll have to not Google later. We'll also need string compare. So I'll provide that link in here as well. So we can go straight to that if we don't remember how to use those. But we need to start length. We already have an example of using this. We already have an example of using sprint F. And then let's continue down here. So we're going to examine handle HTTP requests in the server.c. You'll want to parse the first line of the HTTP request to see if it's a get or a post. Okay. We're going to use SSScanF. We already have an example of that, how we're going to use that. And I would just say, make sure you're paying attention to all of these little notes and hints. We're going to use string compare, and you'll have to use an if-else block with string compare to get the job done. So this is just a preview of how you're going to do it, and hopefully this helps you out. So if you're wondering right now, I know a lot of people had this question last week. How do I get started? What am I doing exactly? You're building a server. That's the answer to that question. You're building a server. And so how am I going to build this server? Where do I start? Well, you start by inventory and everything. And then we actually have steps where your first step is going to implement send response. Okay? And here's the point to today. I'm going to leave it up to you because your job is going to be asking questions. If you get to send response after doing your inventory and you're saying, well, what's the first thing that I need to do? Well, first, we actually talked about this today where we have steps, and I provided these steps to you guys. No. Oh, these are the steps. So let me actually just provide this real quick. So before I can send a response, I need to build a response, right? So then we already have a kind of guided demo on how to build the response. So if you get to a point where you ask yourself a question, well, what am I doing? Or what's next? then you should reach out to a PM or an instructor, but preferably the PM will reach out to the instructor if we can't answer it or we talk amongst ourselves. But you want to inventory what's there. You want to start asking questions. And when you get to a point you can't answer the question, then reach out for help. And we will try our best to answer that question in a way that's going to help you in the right direction. And so everyone should kind of know how to start this week, because we provided some examples of how to build the response. But there may be a point where you walk into something and you say, you know what, I don't know what's the next step, or I'm not getting the output I'm getting, or we're hung up, or we're doing this. But we talked about a couple of things there. If we're hung up, it's most likely some type of formatting issue, because we know if we don't get the right information or enough information, it stays there. If we're getting a invalid response and we're, okay, I'm not getting the response that I'm supposed to get, then that may be a problem with something in our implementation of our response or our HTTP request. Maybe we're not prepared for everything. So we have to build everything out and just follow the instructions and ask as many questions as possible along the way, and we should get there. Today is one of those days that if you implement something very powerful, or you start off with a good, what's the word I'm looking for? I used to run track. If you jump out the blocks pretty good today, where you started off really fast and not in a speed concern, but in a, okay, I'm actually building this thing out and I got the MVP on day one. You can get the MVP on day one, make it to the finish line for day one, which I would say trying to implement the first 3 steps would put you in a good position. Then it's going to set the tone for the rest of the week, because it's the same project we had last week. And if you remember last week, that first day was the bulk of everything that you had to do. And so it's going to be a lot like that today. We can get it implemented. We can get the MVP today. Then the rest of the week should be pretty just like adding on. So any questions before I let you guys go? Any questions? Do you have a question right now? Like, okay, when I get in that send response, what do I do? This is the time to ask it, or, you know, after lunch, once you inventory. If we end right now, I would say take a look at it for 10 minutes and then come up with a plan. Literally come up with a plan. I've stressed this since the beginning of my first PM group. Come up with a plan. And it doesn't always make sense. And I can't say as a student that I always did it, but there was times where I learned the lesson and I said, okay, you know what? I didn't do a plan last week. And then I'm going to come up with a plan. And I'm going to tell you the truth. I came up with a plan and I said, oh, that worked pretty good. And then I said, all right, I did pretty good last week, so I'm not going to do a plan. I'm just going to go back to the old way. Then I probably ran into some trouble. And then I said, all right, I better go back to the plan. So stay consistent with the plan. But I can tell you that when I created a plan, I probably had a better time at it than when I didn't. And I probably created more plans after I had a bad week or a slow starting week than I did just originally in the beginning. So just a wise man learns from the mistakes of others. Kind of like someone touching the stove. Oh, that's hot. Don't touch the stove, you know, and your head should be popped up. So I share that experience with you guys because I haven't always been the perfect coder and this and that. I'm still not the perfect coder, but cool. If we don't have any other questions, I will let you guys go. Please reach out. Please use your resources. Good luck. Happy hacking and enjoy your lunch. Have a great day, everyone.